So before we begin solving power functions, we're going to talk a little bit about solving equations or finishing off math problems to get a specific value. So on your screen, I have a set of equations. We're trying to figure out what do I have to do to 2x equals 12 to find x, 3/5 x equals 15. We're going to do that equation to find x. How do I finish off the other equations so that the value equals 1? This is important for solving what we call power functions. A power function, unlike a exponential equation, the variable x is in a different location. You might recall that for power functions, it's y is equal to your number, which is called a, times b to the exponent of x. So in an exponential, the exponent is the x. In a power function, the base is the x. So it's just a different location. It will definitely produce a different shaped graph, which we'll be talking about next week. But for today, we're just going to talk about how do we solve for this variable here. A couple of days ago, we talked about an equation like this, where we were actually estimating what the exponent would be to get to a specific answer. And so today what we're going to be talking about is how do I figure out what this number is so that when I cube it, I'm getting really close to 150. Or if I take this number here and take it to the 7th power, how do I figure out the answer so it's really very, very close to 396. So to get started, we have to be able to solve equations or finish off an equation so it has a specific value of 1. So in the first problem, you probably are used to just dividing by 2. Another way of doing this problem is that you can multiply both sides by 1/2, because 1/2 times 2, or half of 2, is 1. So whenever you're solving an equation, you're trying to get the value being multiplied to the x to always be a 1. In the second problem, to get a value of 1, we would multiply both sides by 5/3, because then that would create a fraction of 15 over 15, and 15 over 15 equals 1. So we'd have 1x is equal to 25. So what we're trying to do is we're trying to create a fraction that has a value of 1. So for example, in this problem here, I'm going to multiply, this is 5 over 1, so I'm going to multiply that by another fraction so I get a value of 1. So to get a 1, that means the fraction numerator and denominator are the same number. Going from like 5 to 2 over 2 doesn't make sense, because 5 times something equals 2. Doesn't really compute real easily. But making this 5 over 5, for example, does compute easily, because I can multiply 5 to some number here to get to a 5 over here. And same thing here, 1 times some number to get to a 5 there as well. So we're trying to make sure that we change the 1 to a fraction, that we are choosing a fraction in which it's easy to get to that answer. So here, for example, you have 3 over 1. I need a fraction. And again, 2/2 doesn't make sense here, because 3 times what gives me 2/2 doesn't work real well. But 3/2, for example, works real well, because I can multiply 3 times some number to get to 3. Same thing here, I'm multiplying by a fraction, and again, 2/2 doesn't make sense, because I'm trying to 8 times something to get to 2. Doesn't make a lot of sense. So if I continue thinking about fractions, hopefully you recognize that probably the best fraction here is it uses 8/8, because multiplying 8 by something to get to 8 is pretty easy to do. So I'd like you to think about, for the last 2 problems, what would you think the fraction would be that would allow me to be able to multiply 3 7s times something to get to that fraction. Again, both numerator and denominator have to be the same number. And at the same time, if you can finish off the first 3 problems. Turn the video off and finish those the problems. Turn it back on when you're ready. So the first problem, to get to 5/5, we multiply the 5 over 1 by 1/5. Because 5 times 1 is 5, and 1 times 5 is 5. In the second one, we multiply by 1/3. We're going to multiply multiply across, 3 times 1 is 3, and 1 times 3 is 3. And the second one, it would be 8 over 1, which is the same as 8. And the third one, the fourth one, we're looking for a number that's going to work, the fractions work for not only for 3, but also for 7. So hopefully you chose 21 over 21, because it is easy to find a number to multiply by 3 by to get to 21, as well as multiply 7 by a number to get to 21. So again, it's not the only one. We could use 42 over 42. Could have also worked. If you're stuck on how to get there, one way of getting to that fraction is just to multiply the two numbers, and that will tell you at least one a number that you can choose to rewrite the fraction as. So 7 times 3 is 21. We can make the fraction 21 over 21. Since 4 times 5 is 20, we could change the last problem here and turn this into 20 over 20. Because we can multiply 4 times something to get to 20 and 5 times something to get to 20. So this one here, 3 times 7 is 21. 7 times 3 is 21. The last one, 5 times 4 is 20, and 4 times 5 is 20. So look at the fractions and see what's happening in terms of the two fractions that are giving us a value of 1. Is there a pattern? Because in that pattern, we can use that to help us solve those power functions on the next screen. So hopefully you recognize that we're basically taking the number like 3 or 3 over 1, and we're switching the two numbers, which is called reciprocal. So 3 over 1, if I multiply by 1/3, it's going to give me a value of 1. If I start off with 2/9, and I want to get a value of 1, I'm going to multiply it by 9/2. So I'm going to switch the 2 and the 9 and make it 9 over 2, so that when I multiply it, I get 18 over 18. So we're going to be using what's called reciprocal. So in this first problem, we're going to multiply the third power by an exponent of 1/3, because 3 times 3 over 1 is going to be 3/3, and that's going to give me an exponent of 1. So we're trying to get, when I multiply these two exponents, an exponent of 1. So we're going to raise this to the 1/3. The parentheses aren't necessary here, so I can write it as 150 with 1/3 in parentheses, or 130 to the 1/3 power, 150 to the 1/3 power, and either way I'll get the same answer. So this would be x to the first power, and when entering this into the calculator, again, not every calculator uses a caret key. Sometimes the key could be like, let's say, x to the y power or y to the x. But when entering the fraction in, the 1/3, I would suggest putting it in parentheses and entering it as a division problem. If you don't put the parentheses in, for example, you'll end up with an answer of 50, because the way the order of operations are done. But if you put it in as a fraction in parentheses, we would find that the exponent, the base of this problem would be approximately equal to 5.313. And if you want to make sure that's the right answer, or at least approximately correct, go back to the original problem and take 5.313 raised to the third power, and see, do you get approximately 150 as your answer? And if you do, then that's hopefully good confidence that you have the right answer. So 5.313 raised to the third power is 149.975. So it's definitely real close to 150. So you can always check your answer by sticking it back into the problem. In problem number 2, we have 7 over 1 for the whole number 7. So we're going to multiply both sides by an exponent of 1/7, or raise it to the 1/7, so that when I multiply the 7 and the 1/7, I get an exponent of 1. So x is going to be equal to 396 to the 1/7. Again, make sure when entering this in, you put the division problem of 1 divided by 7 in parentheses. And we get an answer that is approximately 2.350. So if I put in 2.350 raised to the 7th power, my answer should be about 396. The next problem, sometimes we're going to have addition, subtraction, multiplication problems to handle. So in this problem here, to be able to solve for y, we have to get rid of the 5 and the exponent 2. So by order of operations, we would get rid of the 5 first to get us back to the power function. Y squared is equal to something. So in doing these problems, be thinking about the y squared, treat it like the variable x or a variable y, as we're trying to get rid of all those numbers and get the power function like y squared or x cubed, or in the problem before, x to the 9th by itself, so that then we can multiply the exponent by its reciprocal to turn it into an exponent of 1. So 380 divided by 5 is 76. Now we're trying to make the exponent on the y become a 1. So the exponent is currently 2, so if I take the reciprocal of that, which is 1/2, then I multiply by 1/2, I'm going to get 2 over 2, which is 1. So we're going to do an exponent of 1/2 to both sides. So 76 to the 1/2 exponent is about 8.718. You think about the fact that, if I put this back in the problem, we have y squared. If I do 8 squared, that's 64, and again, the number here is 76, and we have almost to 9. 9 squared is 81, so it seems reasonable that 8.718 would be the right answer here. I'm going to go ahead and leave the next problem for you. If you go ahead and complete that on your own, and then turn the video back on, we're going to move on to the next screen, and then at the end, I will show you the answers to problem number 4. So in this problem here, problem 5, again, we have order of operations to deal with, so we get that x to the 4th by itself. So the first step would be to add 9 to both sides to get 360. So I'm going to leave these last 2 problems also for you to complete. If you go ahead and complete them, and when you're finished with 4, 5, and 6, turn the video back on. So in problem 4, the first step is to divide by 8 to get the x to the 9th by itself. To turn the exponent of 9 into a 1, we would multiply the 9, or 9 over 1, by 1/9. So 1,720 to the 1/9 is 2.288. So in problem number 4, we're going to divide both sides by 8, and that will leave us with x to the 9th. To get 9 to become an exponent of 1, we need to multiply the 9 by 1/9. So we get 215 to the 1/9, and that's about 1.816. So if you think about, you're taking basically a 2 and you're raising it to the 9th power to get to 215. So you're going to get a lot of small answers, especially if the exponents are bigger than 5 or bigger, just because when you're multiplying 3 times 3 times 3 times 3 times 3 5 times, you're going to get an answer that is in the 300s. If you go to 3 to the 6, I think it's over 1,000. So it doesn't take much to get an answer into the thousands. Problem number 5, first step, hopefully you did, was add 9 to both sides, and you get x to the 4th is equal to 360. To get the exponent of 1, we need to multiply the 4 by 1/4. So we're doing 360 to the 1/4, so it's about 4.356. And then the last one, to get the exponent of 1, we got to multiply the 7 by 1/7. So again, we're trying to multiply by reciprocals here. That gives us 20,135 to the 1/7 power, and so it ends up being 4. So if you think about, you're doing basically 4 to the 7th power. 4 times 4 is 16. You multiply by 4 again, it's 64, and then you get to 256 the next time, and then the next time you're over 1,000. So in 4 fours, you're over. In 5 fours, you're over 1,000, and again you're going to multiply by 4 each time. So the answer is going to get really large. So if you're not sure your answer's right, stick it back in the problem and make sure that you get the right answer, or get approximately the right answer. If you have any questions, let me know.